Hi, in this video I'm going to show you how to calculate average variance extracted and VIF, so AVE and VIF. So for calculating average variance extracted, first you need the factor loading of each item in your construct. So here I have this is a confirmatory factor analysis for this self-awareness construct, and you can see the factor loadings are down here. Okay, so to calculate factor average variance extracted, first you need create a new Excel spreadsheet. We call it AVE. Okay, so we need 3 columns of values. The first column is lambda. That's the factor loading. Okay, so the first column is lambda, and the second column is lambda squared, and the third column represents epsilon. Actually, we don't need the third column, we just need the first 2 columns to calculate the average variance extracted. So first you need all the factor loadings typed up in the first column. I used STD-YX standardization results, which is typical in a confirmatory factor analysis. Okay, 0.672, 0.75, 0.523. Alright. So I got all the factor loadings here, and then in the second column I'm gonna square each of the previous ones. So let's see, because this times itself, so that's a square. Okay, and I'm gonna autofill this whole column, and you need the sum of the lambda square sum together, and then you need the n, the number of factors in this construct, which is 6, and then the AVE equals the sum of lambda square divided by the n. Okay, so that's your average variance extracted, and I'm going to fill in my table. So that's satisfaction to self. The AVE is 0.351 actually. Okay, so just go ahead and calculate the AVE of all your constructs. And for this VIF, that's a measure of multicollinearity, and I'm gonna show you how to do that in SPSS. So you need regression, and this is a bit weird that so to calculate VIF, you will find all the indicators of that one construct. So here is I'm gonna calculate the VIF for, let's see, a self-control. Okay, let me do self-control. So I used 6 items to measure self-control, and to calculate VIF, I'm gonna throw one of the 6 indicators in the dependent variable box, and the rest of the indicators to the block, the independent variables. Okay, and then in statistics, uncheck everything except for multicollinearity, and hit continue. Okay, so go to your VIF. So that's represent the relationship between that dependent variable, which is one of your indicators, and the rest of indicators. So we can see that the VIF here are smaller than 3, which is good. Means that there is not much multicollinearity in this measurement. Okay, so I'm just gonna write it down somewhere. Let's see. Let me write it down in this Excel sheet. Okay, so this is for cell control. Obviously, for measurements that use one item, you can't calculate VIF. So this is a first one, and the VIF is 1.47, 1.28, 1.51, 1.50. What I will do next is to go back to my linear regression and rotate this list. So I will move the previously used that dependent variable to the bottom of the independent variable list, and move the next indicator to the dependent variable box, and use the rest of the indicators to predict that independent variable. Okay, that dependent variable. So got another list of VIF. So you're just gonna rotate that list of indicators and get the VIF, a couple of VIF for each indicator. And the general rule is that if you have larger than 3 VIF, that's an indicator of multicollinearity. But otherwise, 1 point something, that's all good. You don't have multicollinearity in this case. And that's it for this video. Thanks for watching, and I'll see you next video.